Let's read out this question. Three infinitely long wires having uniform linear charge density lambda are placed along x, y and z axes respectively. Alright, so one is along this is lambda, this is lambda, this is lambda. Find electric field at point A, comma A, comma A. Alright, it's a symmetric point, we can see this, it's given in the diagram. So we need to find EP vector. Now the situation is same for all the three wires, so let's just focus on one of them. So if I focus on the wire which is along the y axis, alright, so I can see that this separation will matter, something like this. So let's call this point as point B, this is the origin, and let's call this as point A. Alright, so the separation between P and the line charge along y axis is basically BP, alright, and that separation I can easily see that is how much, under root A square plus A square, so that is root 2A. So due to this line charge, let me just call it, let's give this some name, wire 1, wire 2 and wire 3. So right now we are calculating E2 vector, okay. So E2 vector, for that the separation is coming out to be how much, root 2A, and we know that for an infinite line charge the magnitude of the electric field is lambda upon 2 pi epsilon naught r. So let's do that. So lambda upon 2 pi epsilon naught multiplied by the separation, and that is root 2A. Now this is the magnitude and we need to report in terms of the vector. Now this electric field will be pointing along BP cap, right, like so, something like this, along BP cap. Now this BP cap is equally inclined to x as well as z, and that angle is basically 45. So what can I write this as? I can write this as I cap plus k cap by root 2. I can do that. So let's write it a bit more simplified way. So this is 4 pi epsilon naught A and a vector, and that vector is I cap plus k cap, right. Now I can similarly calculate E1 and E3. So E1 will be some magnitude, they'll again of course come out to be same because of the symmetry of the situation, and that vector for x will come out along y and z. So I'll write j and k. E3 will be same coefficient and vector will be along x and y, so there will be I plus j. Alright, I hope this is clear. So EP vector will be lambda upon 4 pi epsilon naught. So if I take 2 common, I'll have all the 3 components only once. So that will be I cap plus j cap plus k cap. So let's just find this. I missed A here. So that will be lambda upon 2 pi epsilon naught A I cap plus j cap plus k cap. Alright. So option 2 is coming out to be correct for this question. Alright. Thank you.